ECS is not essential, but for me, I have some uses that I'd like to get out of it, especially for longevity of this project. I'd like to get this engine as robust as it can be, and essentially I'd like to use it in the long run. So I want to kind of do the necessary implementations now and designs which will make it a lot nicer to use in future. One of them designs is ECS, which is an entity component system. Comprises of essentially 2 to 3 kind of separate things. So you've got your entity components or entities that have components, and then you have systems. So what that essentially solves is one is class inheritance issues, and 2, a way to quickly aggregate and collect or query components in your game engine. So for example, I want to get all players in the scene and essentially add an effect to them, or I want to get all the visible tiles and pass them into the collision system for processing. And with ECS, that's very straightforward. What it also allows you to do is dynamically pass components between entities, meaning that an entity could essentially, a player could drop his collision component, which allows him then to pass through walls, that kind of thing, or pass the player component to a vehicle instead of a player, so control the vehicle, that kind of thing. So in traditional game design, you will see a lot of essential inheritance, and there's nothing wrong with that. It's been done for the longest time, but what it does present is potential roadblocks when you're quickly prototyping entities in your game engine, and then you're going to have to refactor stuff because you're hitting the inheritance roadblock here, where essentially you've defined a bird class that extends an animal class. You want to now make a bat class, but it already extends a marble land bird, and that is fine. You can get around that by redesigning your entire inheritance system, your architecture, but it's a lot of effort, and you may refactor something like an entire set of base classes for 2 levels or 1 level, and then decide that, by the way, we're going to add this other character or item in the game, which then requires a huge refactor again. So it quickly becomes a huge overhead to the project, something I want to absolutely avoid. What ECS allows us to do is essentially make it completely eclectic, where you create an entity. So this would be an entity, and an entity doesn't mean anything. All it is a thing in the system. So we essentially can give entities a translation component, a rotation component, etc., etc. So these could be a collision component, or a player input component, or a sprite component, or animation component. And what ECS allows us to do is essentially change and dynamically drop and add components on the fly, even delete a whole set of components. So if you were to delete all these, your entity would essentially disappear. And that kind of operation is great for game development, because you can quickly prototype and interchange, redefine what an entity is. Going back to the older inheritance, for example, you may be familiar with Oddworld on PlayStation 1 and PC. The source code is reverse engineered on GitHub, and what they've done is essentially for the biggest part, you have a base game object, and everything extends that base game object. So Abe, the main character, will essentially just extend a game object, and they'll do this for multiple things like different types of enemies, items, animations, that kind of thing. But essentially what you see in the source code, for them to avoid this inheritance issue, is they only really extend the base class once or twice. They don't really go that deep. I guess that has always been a concern in developing games, is hitting that issue there in the source code. So what ECS essentially allows you to do is avoid that and keep this very eclectic and very open, so it can be quite dynamic. So apart from using ECS to solve the diamond issue, essentially the reason I chose ECS was for the fact that there's a ton of information online. There's loads of discussion boards, Wikipedia's, YouTube videos. There's a ton of resources out there to already understand this established framework in order to implement it. You've got examples in Unity and whatnot, so there's a wealth of information online if you're willing to go and dive into it. For myself, I couldn't find anything fully flushed out from start to end integration, raw C++. A lot of people use, for example, Unity or whatever for their first game engine, and it's already implemented and Unity takes care of that. But for myself, I was trying to implement this from scratch, so a lot of information online is focused on the entity and components themselves, and I struggle to find the latter half of that where I'm trying to get the full implementation with the database side of things as well. So apart from all the information online, another great part for ECS is the database, because it essentially depends on your implementation, but essentially acts like a MySQL database, where you can say, get me all the entities that have these components, because you could be in, for example, your rendering system, and then you can quickly capture the correct entities to process in that system, right? And that's a great part of ECS as well. I mean, you could potentially integrate that kind of behavior in a non-ECS system, but tethering off the tail end of why I'm integrating ECS, this is another plus to that. So, because of that design, it also allows systems to be, and code to be, compartmentalized and stitched into their own files away from a huge main file or whatever. So you've got a nice architecture and a good housekeeping on your project. So what I struggle to find online is essentially what I have in front of me here. So you'll see a lot online where they're essentially showing entities and how each entity has their own set of components, and they then translate to archetypes and whatnot. I'm not going to worry about that right now, because I'm just trying to example how efficient it would work as a database. So say, for example, you load a level, that script picks up your level editor file or however you've implemented it, creates the entities with the components, and it essentially inserts them into a database. So when you boot your game, essentially this is happening. It's creating all the things, e.g. entities, to go in your game. You could even, for example, I have tile maps as entities as well, but they're dealt with a little bit different in terms of querying. But everything in your game essentially boils down to being an entity or a tile, for example, and they get placed into a database. So in my case, we've got entities and I have tiles placed into a database where I can query. But for now, I'm just exampling raw ECS, so it's just going to be entities into a database. Your game's booted, and you have constructed your runtime database. So everything's loaded into memory. It's in the database. So when the game actually runs, every frame, for example, it could come into the rendering system. And what's nice about ECS is it allows you to just put a rendering system in its own place, in its own file, so the code's nice and clean and tucked away. And then you can have other systems like collision systems, player input systems, and so forth. And they can be as lightweight or complex as you want them to be. It's literally just a class, right? So any system is just a class, but essentially you load the database into the, as a pointer or whatever, and you interface with the database. And what's essentially happening here is I'm saying to the database, I'm the rendering system, please get me everything with a position and a sprite. So that's taken care of via the query. So I can construct the query and say, this query looks for position components and sprite components. And what that does is essentially asks the database which of these entities has these components, and the database takes care of all the overhead and optimizations and lookups and however you design the database. You want to put some caching in there potentially, it'll return them components in that list. And that's fairly straightforward, to be honest with you. It's a system that essentially just collects the correct entities. And you can have how many queries you want. You can say one query could be just for position, another could be with positions and collisions for whatever reason. You may not want to do that in the rendering system, but perhaps you want to render the collision maps for debugging and that sort of thing. So it's looking at it from this point of view, it's very straightforward. The complexities come where you want to optimize the database, but for now, this is essentially the best reason for me to use ECS along with the diamond issue. There's some slight issues. As with anything, there's caveats. There's a slight overhead when you're operating on this kind of system, hence why I'm going to go into another video with archetypes which solves that. So if you were making a very low level game, you would potentially don't need to use ECS, and then you can just essentially do everything via arrays and pointers and make things very low level and efficient. But this system will essentially provide a little bit of overhead but a lot of performance when you've got a larger collection. Another issue may be with debugging. If you're not writing the correct implementation, you might box yourself into a hole where you are struggling with debugging certain entities being processed. But there's definitely ways to do that, but it just takes a bit of love and care. The third issue is this may be a huge step for new developers to implement their own ECS from scratch. A lot of people may use third-party options, but what that does then is it kind of detaches you from the learning experience of implementing an ECS system. So there's some pros and some cons, depends where you are in your development career and what you choose to do. But for me, I thought this was a lovely little challenge, and this is very familiar to me because I work in web. Very familiar with databases, MySQL and so forth, and you can look at entities as just tables with rows in them, and your query is essentially aggregating these rows from different tables and then passing it into your application. Very straightforward stuff. So I've done a very bare bones implementation for now, but I'm just going to approach it ad hoc and just beef up the query system when I need it. I'm not going to go nuts and overdevelop it at this point. Like this is functioning as I need it at the minute. So those two main points about ECS is essentially the reason why I chose it, and I chose to implement ECS at a very early stage. Essentially, as soon as I started rendering stuff to the screen, I found out about ECS, and I decided this is probably for the best in the long run. So I guess it took me a good month essentially to get it fully flushed out, as I was new to doing programming in C++ with handling pointers on the stack and dealing with heap, and then I had to learn about smart pointers and whatnot. But the next video will go into essentially archetypes, which is a way to optimize the collection for entities.